Hello and welcome back to my class, my channel, and today we'll be moving on to the next unit, which is warmth and coldness. Well, warmth and coldness, this video will really just be a little bit of a review from everything you've learned and probably in previous years when it does come to chemistry and science, really. And we're going to be, in this unit, really focusing on a specific type of energy. Last unit we were talking about mechanical and kinetic. This unit we'll be talking about thermal energy and how we can apply it to our real world, obviously, and how it applies to our physics concepts. So let's begin. So first we're going to talk about kinetic molecular theory. What is this, you may be wondering? Well, kinetic molecular theory is basically how objects are made up of particles that attract each other, that have potential energy and move around. So basically, objects are made up of particles that attract each other, which is basically just potential energy, and they move around, which we know to be kinetic energy. So, just a little recap. We have three types of matter. We have a solid, where the particles are very, very close together. We have a solid. Then we have a liquid, where the particles aren't as close together because they're able to move a little more freely. And then we have gas, where the particles are very far away from each other and aren't very close. So something that we can know about these is that heat will often make the particles vibrate faster, right? Heat makes particles move around a lot, and the more heat we add, the faster they move. In gases, they'll obviously have the most space to move around, and in solids, they may not be able to move around. They'll really just be able to vibrate faster. And when we apply heat to just liquids, they can move faster, and they'll have more. They won't have as much space to move around as gases, but they'll still be able to move around a little bit more. So, when we're talking about melting and freezing, well, to go from a liquid, we can label all of them right up top. Liquid to solid, and gases. We can either go from a liquid to a solid by freezing. Pardon me. Go by freezing. Or we can go from a solid to a liquid by melting. Similar to how water can go from a liquid to a solid by freezing it, and then how we can boil it, and how we can melt it and it'll become water. The way that gases go to liquids is by condensation. You may see condensation sometimes early in the morning when you wake up on your window. And how liquids can go to gases is just by boiling. So heating them up until they start to evaporate and become gases. So now that we understand that, let's talk about what thermal energy is. So we can talk about what is thermal energy. Well, thermal energy is basically the total kinetic and potential energy possessed by a substance. So total kinetic and potential energy that a substance substance has. So this can often be looked at, and remember, like, kinetic energy can only be, all these forces, remember, only transferred from one another. We cannot create or destroy energy. So total kinetic energy is just thermal energy is really the total kinetic potential energy that a substance has. That substance really that the particles of the substance has. You can feel the thermal energy when you blow into your hands, and we can feel thermal energy really like all around us. And when we talk about the transfer, thermal energy can only really be transferred from hot objects to cold objects, from hot to cold. So a hot object can transfer thermal energy to a cold object, not vice versa. So now next thing we're going to look at is what temperatures and thermostats are. You obviously have probably heard about what thermostats and what temperatures is. Every day you might wake up and you may look, oh, what's the temperature for today, or what's the weather like today? And we know that thermostats or thermometers help us determine what that is. But the temperature, again, in a more theoretical sense, is just the average kinetic energy of the particles that are maybe in a certain substance, that are in a certain piece of matter, right? And a thermometer is basically just a device to measure temperatures. And oftentimes they're made up of glass with mercury or alcohol inside them. Now we can talk about what types of units we use to measure the temperature. And we've often heard a lot of these units before. We know that there is Celsius. Yeah, Celsius. We have, pardon me, let me rewrite that. We have Celsius. We have the Fahrenheit. And we have the Kelvin. Now, these are all different types of scales. Obviously, if you live in Canada, you've heard of the unit we use, which is Celsius. Anytime you talk about, oh, it's 10 Celsius outside, or 10 degrees, we're really referring to Celsius. In America, they actually use Fahrenheit as their unit of measurement. And that kind of determines how they look at like the weather, and they'll be like, oh, it's this much Fahrenheit, it's this much Fahrenheit. There is a conversion between them that we'll talk about, or that you can really do. It's not too hard, but the main difference is that Celsius, or 0 degrees, is the melting point for water. Water really melts at 0 degrees or Celsius, and we know that the boiling point is at 100 degrees. For water. Water is typically our really basis for measurements when we're talking about boiling and melting points, because it really differs between the type of substance you have, but we're talking about water here. For Fahrenheit, 0 Fahrenheit is again the melting point of, pardon me, it's the melting point of, pardon me, of brine, pardon me. So you may ask, what is brine? Brine is a salt. Is salt water. It's a mixture of water and salt. Pardon me. That's what I was looking for. Because 0 Fahrenheit isn't the melting point for water, but for the salt in the water. So it's a melting point for the salt. And 100 Fahrenheit is the melting point. Is the boiling point for brine, or the salt again. And the next type of scale that you may not have seen, or you may not be familiar with really, is Kelvin. Kelvin is basically Celsius plus 273. Why we really use Kelvin? Yeah, it really depends on the context, because in some of our units here, we will be using Kelvin as our measurement, because that is a term that we use in physics sometimes. And the benefits to using Kelvin are, it gives us a reference point for like an absolute zero, and Kelvin helps. Kelvin is basically, in temperature is directly proportional to the average kinetic energy of particles, and using Kelvin aligns the temperature with the energy, without offsetting anything really. Kelvin is just really the universal standard for kinetic and thermal energy, and those are just some things we have to understand when we're using Kelvin, because it's the unit that we're going to be using throughout this thermal energy unit. But 0K is basically just equal to the absolute freezing, or the absolute zero. So no kinetic energy at all. So there's no kinetic energy at this point. That means there is no movement of particles. Everything's absolutely frozen. And basically, if we want to talk about how we get Kelvin, or how do we convert it, well, from Celsius, temperature in Celsius, we do T Kelvin minus 273 if we want to get our degrees in Celsius. If we want to get our degrees in Kelvin, again, we just do TK. We move the 273 over. We do T Celsius plus temperature of Celsius plus 273. That's how we can convert between all these different units. And if we want to talk about more specifically how we can possibly use this in a question, we'll look at that in just a few seconds right now. So now we have a sample problem in front of us. It says alpha alcohol boils at 78.3 degrees Celsius. What is this temperature in Kelvin? We just go straight into our given. We know that the temperature is in Celsius, so we can go TC is equal to 78.3 degrees Celsius. And we're looking for it in Kelvin. So we're required to find Kelvin. Now we can go into our analysis. We know that TK is equal to TC plus 273, as stated up here. And now we can just go straight into our solution. So solution is equal to TK is equal to 78.3 degrees Celsius plus 273. And now you can just plug this into your calculator, and you should get 351.3. And because there's 3 significant digits here, we can run out to 3 significant digits. So 351 K. K is the unit we use for Kelvin. We use K as the unit of measurement. Now that we understand that, that concludes really the whole video. That is just a quick refresher on everything we learned about particles and going from heat to cold previously in maybe science classes. And now we have a new unit of measure, which is just the Kelvin. And we'll be using this throughout the next little portion of this course, especially with heat and capacity and changing from states of matter. Anyway, I hope you enjoyed this video, and remember, physics rocks.